All right, hey everyone. So this is the walkthrough for Lab 2. It's going to be very similar to the last one, Lab 1. We don't have the PowerPoint ready yet, so I'm just going to go through and show you the videos that Jamie did of the bromine test and the permanganate oxidation test. So first I want to show you where this information is. This lab guide for this week is actually really good and will probably give you all the information needed to complete the lab. Um, yeah, that in your lecture, right? Being able to name these compounds, very important that you're able to name these compounds because when you get into the numbering, 2-butene, for example, um, it's very important to be able to distinguish between the different molecules. So when you go Googling looking for images, like you did in lab one, these more complex molecules, they might be just slightly different than another variation. So it's important for you to recognize and be able to name these different things, uh, and be able to verify that what the image that you're putting on your lab report is in fact the molecule that we're asking for. Okay, so just be able to double check yourself, read the little script below the images, make sure that it matches what you're supposed to be looking at, because it's very easy to get slight variations in different compounds and molecules. Okay, so with that being said, let's go ahead and jump right in. Um, this is all the information is in the lab guide. You can also find the lab guide in your Chem 21 lab report. Up at the top of experiment 2, you'll see PDF lab guide. Click that, open that up, and it'll be that same lab guide that I loaded for you on CougarView. Okay, same thing, just goes through uh, information like a pre-lab and then the procedure that we do in the lab to carry out the test. Okay, let me X all them. Now let's go through and looking at part A. So for this one, you're going to draw the structural formulas of like 5 different compounds. These are fairly simple compounds, but we want you to go ahead and get the practice in using this um, Chem 21, this molecule builder. I forget what they call them. But you just go through here, draw the structural formula, and then submit. And I think Jamie actually shows uh, these molecules built with the little modeling kits that we have. So I'm going to go ahead and jump in here. The tests are both on this video. The bromine and the permanganate test are also here. So just kind of stay tuned or skip to those portions of the video if that's all you need to see here. But Jamie does the models of each molecule. You'll see there the double bond. That's how we represent the double bond in these molecular models. It's propene, cyclobutene. Now, if it doesn't have the number, that means there's probably some type of symmetry. So it doesn't. There is no one cyclobutene, two cyclobutene. Uh, the double bond is always one, so no matter where it's at, it would always be the one position. Now, trans 2 butene can have different variances. There's a number in there that means it can be a different spot for the double bond. It could have one butene. Trans versus cis, meaning that the molecule continues on the opposite side of the double bond for trans or on the same side for cis. And this is the triple bonded ethyne. Okay, that is a triple bond. And the reason those are important in this lab is because we're going to do bromine test and permanganate test, and whether or not has a double bond present, uh, different reactions might occur. One is an addition test, the other is oxidation test. So it's 2 different ways to determine whether or not a double bond is present. Okay, so Jamie's going to go through and do the first bromine test on cyclohexane, which is an alkane, single bonded uh, hydrocarbon. And bromine has a reddish color in general. Okay, so in this experiment, if a reaction occurs, um, then the bromine will add to both sides of the double bond. Okay, and so that means that the bromine red will go away. Now, all this information is in your pre-lab discussion with Dr. Taylor, and it's also in the lab manual, the PDF lab guide. So, notice that on cyclohexane, the red color persists. Okay, next up is cyclohexene. So, hexene meaning there's a double bond present. And a couple of drops of the bromine. Okay, so the red did not persist. The color disappeared when it hit the cyclohexene. So that means that a reaction has occurred that has changed the red bromine into something that's colorless. Okay, so I'm not gonna give away the answers or whatever, but all this information is in, like I said, the pre-lab discussion and the lab guide. So now we're going to do two unknowns, and based on what you saw earlier, you're going to predict whether or not the unknown has a double bond or does not. And like I said, these videos are a little too long to add to Cougar View um, because they max me out at like 2 gigs. I would just add that on here. I might can actually. Let me see if there's something I can do to make it smaller. Okay, so the red did not persist in unknown A. So that is more like the second test that we ran. I'm not going to say whether or not it was hexane or hexene. And now this is unknown B, and it persists, right? That red's really dark, so the bromine is not reacting with anything in that compound. All right. So now you'll make those observations on Chem 21. Let me show you where that is. Right here. You'll make those observations about the hexene, the hexane, and the unknowns. Okay. And fast, slow. If it's fast, that means there was a reaction. If it's slow, that means you didn't see a reaction. And the reason that is because these reactions will occur with bromine, for example, will occur with alkanes just over time in general. They'll link up with the hydrocarbon chain and trade out a hydrogen atom. Let me show you. This is also in your lab manual. Here you'll see this is a reaction for an alkane in bromine, but it occurs very slowly. So that's why the lab manual says fast versus slow as opposed to saying reaction, no reaction. Um, and I didn't see a spot for you to list the identity of your unknown. Um, so let's everybody do. Oh, okay. It does have a identification. So let's everybody just do one. Okay, so unknown A. Everybody do unknown A. I think that'll keep it simple. I'll make another little note of that under this video on Cougar View. All right, let me go back to the video. That was the bromine test for addition. And I think we concluded that we're going to do number unknown A, so number one on the lab report. So now the permanganate is purple naturally. So if no reaction occurs, then it'll stay purple. And then if a reaction occurs, this one actually makes a brown, dark brown kind of mud color when it reacts. Okay. And this is oxidation. So we're adding an oxygen to some portion, and it makes the resulting manganese makes a manganese dioxide, and that's where that brown color comes from. It'll focus up. Okay, so that is not purple, that is brown. All right, so a reaction did occur there. It must have been a hexene. All right, so now they're doing cyclohexane. The dog's messing with me over here. All right, 5 drops of cyclohexane, um, 15 drops of the permanganate. Oh, sorry. And that's a very bright purple, violet purple. So no reaction occurred there. Left cyclohexene, right cyclohexane. All right, so now she's going to test the unknown. And this is unknown A, so this is the only one we're really concerned about. And once again, 15 drops of permanganate. I really didn't get a good look at that. Let me see if she comes in a little closer. All right, so the left side is unknown A, and now you can see it pretty clearly. So kind of brownish for unknown A. All right, and that should be everything that you need to complete the lab. Let me just kind of double check. This was the potassium permanganate test. Write the IUPAC names for these molecules, no problem there. And make sure you enter number 1 for your unknown. And I think that'll be about it. So just email me if you have any questions, and I will see y'all next time. Bye.